Hi there, my name is Derek McNeil, and I'm doing a video on two-dimensional kinematics. We got a problem here. We have the highest barrier a projectile can clear is 13.5 meters. When the projectile is launched at an angle of 15 degrees above the horizontal, what's the projectile's launch speed? So what I want to do is I want to draw that picture first. So I've got a projectile that's going to be launched at 15 degrees above the horizontal. And then some distance away, I'm going to have a wall that's what I'm doing. Sorry, we have a side conversation going on at the exact same time. 13.5 meters high. Okay? So what we've got to do is you got to figure out what the velocity is of my launch. Okay? So, this is the highest possible point that the projectile is going to travel. It's not going to get any higher than this 13.5. Well, that's an important piece of information, because this 13.5 is going to be the maximum height of this motion. Okay? And when I fire at 15 degrees, so I don't know this distance, but I do know this height. Okay? Cool? So, let's approach this problem by first saying that V initial is going to be V initial in the X, or in the Y, and V initial in the X. Okay? I also can say that, talking about this X motion, that, I'm going to draw a little arrow, that X distance is going to be equal to V initial X times time. Okay? Cool. And then I can say the exact same thing for that one, saying that in this case I have acceleration, so I'm going to have 13.5 meters is equal to V initial in the Y times time plus 1/2 -10 for the acceleration due to gravity times time squared. Cool? So that's what I'm dealing with right now. Now what I need to do is I need to say, well, there is a relationship between this one and this one. There is a relationship between time and time. Okay? So all of those have relationships with each other. So if I say, and I should probably grab a rag, but if I say V initial is equal to V initial in the Y plus V initial in the X, that gives me the relationship between the X, the Y, and the initial velocity. I also have T in the Y and T in the X. Well, T in the X is the amount of time it takes to go from here to here, and Ty is the amount of time it takes for that particle, or that rocket I should say, to travel upwards 13.5 meters. Okay? Cool? Does that make sense so far? Cool? Alright, so let's clear off a little bit of a space here. I'm just going to start organizing my thoughts. I have that height, that 13.5 is equal to V initial in the Y, T, plus 1/2 -10 T squared. I also have my distance is equal to V initial in the X, T. And what else do I have? Well, I have another magic number, because when we reach the maximum height, this point right here, my velocity in the Y is equal to 0. If it isn't equal to 0, if it's greater than 0, then that means the object can still go higher. If it's less than 0, then that object is going to hit that wall. Okay? So at that magic point, we have V initial Y is equal to 0. Okay? So that gives me yet another equation that relates time to velocity. So I can say V final in the Y is equal to V initial in the Y plus -10 T squared. Well, I know that V final is equal to 0. I don't know what V initial is, and I don't know what T, not T squared, T is. But now I have a situation here where I have two constants and two unknowns. I have this one, this one, this one, this one. Okay? So I have everything I need to know. This one turns out to not be all that helpful, but it's a piece of information that I might have needed elsewhere. But I'm looking at 13.5 is equal to v initial t plus 1/2 negative 10 t squared, and 0 is equal to v initial y plus negative 10 t. If I solve for t, I end up with, bring this over to the other side, negative v initial y is divided by negative 10 is equal to t. The negatives cancel off, and now I have exactly what I need, because I can take that and plug it into those 2 points. Okay? Oh, I should say v initial y. Cool? So that leaves me with 13.5 is equal to v initial, and then I'm plugging it into here, times v initial divided by 10 plus 1/2 negative 10 v initial in the y squared over 10 squared. Only have one variable left, and the great thing about it is that, I'm going to see if I have enough space, is that that's v initial squared over 10 plus 1/2 negative 10 v initial squared divided by 10 squared. One of those goes away, and I've got a relationship here. If you don't see it, oh, and I should put that y there, I have 3.5 is equal to v initial squared divided by 10 plus 1/2 v initial squared divided by 10. Oh, there's a negative sign. When I took the 10 away, I should have carried away that negative. Okay? So the very last thing, and let me just clear off the space in the very top, because you're not going to need all this space, so I'm going to re-express that. So 13.5 is equal to v initial y squared divided by 10 minus 1/2, because I forgot that negative sign, v initial y squared divided by 10. Same common denominator, I can bring them together, and I'm left with 1/2. Okay? And at that point, it's a simple solution. Carry that over, have a 20, multiply by 20. So we get 13.5 times 20 is equal to v initial y squared. Ta-da! And once I've got this, I can go back to that v initial is equal to v initial on the y. I'm not really giving myself enough space there. Once I've got that v initial on the y, I can go back to the idea that v initial is equal to v initial y plus v initial x. And that's going to turn out to be v initial I sine theta. And you're done. Okay? Cool? So that was problem number 2 on two-dimensional kinematics, the second set.